All right, today's notes is 11.5. We're going to finish up angles in circles. All right, now we've known in the past day, we've known a couple things. We know about what central angles are. Central angles, the angle is equal to the arc. Right? An example of that is if you have a circle with the center, the angle is at the vertex is at the center, and the angle is equal to the arc. We've seen that before, yeah? Sure. Then yesterday we talked about inscribed angles. And we talked about that the angle equals 1/2 the arc. All right, and we talked about a couple ways that looks. Yikes, what happened there? Circle, the inscribed, the angle is, the vertex is on the circle like that. Or it could look a secant and tangent. And when we're saying that the angle is 1/2 the arc, the angle is equal to 1/2 the intercepted arc. All right, so in this case it would be that. Okay, so think about where this vertex is. Here the vertex is at the center. Here it's on the circle. Where else could the vertex be? Well, the first thing we're going to talk about is if the vertex is inside the circle. Inside the circle. And let's tell you what it is. The angle equals 1/2 the sum of the intercepted arcs. What do you mean by that, Smith? Let's do an example here. If we draw a circle, and let's draw an angle like this. This angle X right here is equal to the sum of this arc and the one behind it. And then the average, it's the average of those two arcs, or 1/2 the sum. All right? Again, another way to think of this is the average of the intercepted arcs, the two that it intercepts. Let's do an example here. So let's suppose I gave you a circle. We're just looking something like this. The angle here is X. This is 40. And this arc here is 20. What is the measure of angle X? All right, well, the angle X is 1/2 the sum. Sum means to add them. So 1/2 the intercepted arcs, the sum of them, 40 plus 20, is 1/2 times 30. So angle X is... Oops, 60. I got ahead of myself. X is 30 degrees. Now, the vertex is inside the circle here. That's why it's 1/2 the sum. So where else could the vertex be? The vertex could also be outside the circle. The vertex could be outside the circle. And if that's the case, the angle equals 1/2 the big arc minus the little arc, or the little arc. In other words, it's going to be 1/2 the difference. 1/2 the difference. So a couple ways that this could look. Let's do an example. Draw a circle. And here you see how this vertex is outside the circle. It's two secants that are hitting this. Now, if this is angle X and this is 20 and this is 40 this time out here, what's going to be the measure of angle X? Well, X equals, angle X equals 1/2 the difference. So it's the big one minus the little one. 40 minus 20. Big arc minus a little arc. So it's 1/2 of 20, which is 10 degrees. So x would be 10 degrees. Let's do another one. Big circle. In this case, we have two tangents. Two tangent hits it right there and hits it right there. And tell you what, I know that this is 200 and this is x. Wait a second, Smith, did you give us enough? Sure I did. Check this out. This arc here is 200. So what is left for this bottom part? Be 160. So go ahead and figure out what x is real quick. The vertex is outside, so the angle x is 1/2 200 minus 160. Big arc minus the little arc. So it's 1/2 of 40, which is 20 degrees. 20 degrees. Outside can get funky. I'm going to give you one more. And then we're going to talk about why this works. Suppose I gave you this. Oops. Oh my goodness. It's another tangent. And this is 50. And this is x. From here to here is x. How are we going to... Oh, and this is y. Let's call this y. Think about how to attack this. Let's see. Well, the angle, 50, is 1/2 the arcs, right? So it'll be y minus x. Y is probably the big one, right? Y minus x. But that's not going to work, right? Because then we would have two variables, y minus x, and we can't solve that. We could say that y plus x is equal to 360, but that's a whole thing. Here's the thing. Instead of y, let's rename this. If this is x, then how big is this piece here? Well, if this is x, the whole way around the circle is 360, right? And this red one's going to be x less than that, right? So this is 360 minus x. Follow me on that? All the way around is 360. This is x, so that makes this 360 minus x. So that means inside here is going to be 360 minus x. That's the big one. Minus x again. So I have 50 equals 1/2 of 360 minus, what's negative x minus x? Minus 2x. Distribute the half, you got 50 equals 180 minus x. Subtract 180, you get negative 130 equals negative x. What is x? X is 130. So in this case, x is 130. If x is 130, then what is y? Y is going to be 230. Word? For sure. So here's the thing. This next part is just a demonstration. This is a program called Geometers Sketchpad. Right here, angle ABC. The measure of angle ABC is 40 degrees. Now, I put ABC at the center. Oops, let me put that back at the... Stop it. Go away. Oh my goodness. Right there. AB is at the center, right? Now look at this. ABC is at the center, so this arc is 40. It's also the average. What's 40 plus 40 divided by 2? 80. Oh, by the way, this is arc AC, and this here is arc FG. Now look what happens. As I take the vertex and move it backwards. What's happening to AC? AC is getting bigger. At the same time, what's happening to FG? FG is getting smaller, right? So that's why it's the average. When you pull it back here to 50 and 30, this one went up by 10, this one went down by 10. 50 plus 30 is 80, average of that is still 40, because as you see, the angle here never changes. So when it's inside, it's the average, right? Until it gets to 72 and 8 is still 80, and half of that is still 40, until B gets on the vertex, or excuse me, on the vertex gets on the circle, then it's still the average. The only thing is the small arc is now 0. So 80 plus 0, half of that is still 40. But then as you go outside, what happens? If the small one is getting small 30, 20, 10, 5, 0, when it gets out, that means that this is like negative. Even though it's not a negative arc, because the way we're moving this vertex, it's like it's negative, right? So check this out. When this is 100, that means this is 20, but since it's outside, we're subtracting the 20. 100 minus 20 is 80. Half of that is still 40. All right, so when it's at the center, it's equal. As long as the vertex is inside, it's 1/2 the sum, or the average. When it's on there, it's 1/2 straight up, and when it's outside, it's subtraction. All right. Hey, go ahead and press pull out worksheet 2. Go ahead and press pause if you need to go get it. But let's do number 1 together. Kids look at number 1, and oftentimes they poop their pants. So let's look at number 1 on your homework tonight. That's a big scary star, right? So here's what's up. They ask you what 1, 2, 3, 4, and 5. We've talked about this before. Don't do this until you're all done with this. All right, so they gave us some stuff. Let's label it. AD is 54. Arc BC, where's BC? BC is 62. DE is 36. FG is 22. Then EF is 78. All right, now look for easy stuff. One of the easiest things are central angles, but there are none here, right? Here's the center. There's no angles going on. However, there is a diameter, right? So if this is a diameter, that means that this is a semicircle. And 36 plus 78 plus 22 is equal to something. What's left for CG? That makes this here 44. Then let's do the other half of this semicircle. We got 54, blank spot, 62. That means this arc here is 64. All right. Once you've got all of your arcs labeled, then go through and look at the rest of them. Let's start with number 1 here, perhaps. It's an inscribed. 1 intercepts angle 44 and 22. The angle is 1/2 the arc, so that means 1 is 33. Angle 2. 2, the vertex is inside, so that means it's the angle 2 is 1/2 the sum of the arcs. Well, it intercepts 54 and 36, which is 90, plus the one behind 2 is 62. So angle 2 is 76. So let's label that 76. Now here's the thing. Once you got 2, look what else that you can do with that. Don't forget about vertical angles, and don't forget about linear pairs. Right? So if 2 is 76, that means that 17 is also 76. And if 2 is 76, 15 is 104. Also, don't forget triangles. Look at the triangle with 1 and 2. 33 plus 76 is 109. So what's left for angle 3? 71. And once again, look for verticals. This line and this line makes angle 5 is vertical. 71. All right, now we can't do a linear pair here, but maybe we can look at angle 4. The vertex is inside. So angle 4 is 1/2 the sum. 36 plus the one behind it is 62. Oh, there's a bell. Which is 49. So now do linear pairs. Here's a straight line here. So here's a straight line here. 49 plus 71 is 120. That means that angle 6 is 60 degrees. All right, and take it from there. Label all of these first, then go ahead and fill this in. All right, so that's your homework. Smith out.